Hello there, welcome to this tutorial. We'll be taking you on problems on bearing and distances, which will lead us to the use of either the sine rule or the cosine rule. So we take the first problem. A student walks 50 meters on a bearing of 0.25 degrees and then 200 meters due east. How far is she from her starting point? Hence, calculate the bearing from her starting point. So in this type of problem, we are going to sketch the diagram for this problem. A student walks 50 meters on a bearing of 0.25 degrees. So we take the point A, that's the starting point of the student. So walks on a bearing of 25 degrees. So from the North Pole, you will measure angle 25 degrees clockwise direction. So and draw the line. So this angle here is 25 degrees from the North Pole to the line of a path is 25 degrees. So to another point, we call it B, a distance of what? 50 meters. So the student walks from A to B on a bearing of 25 degrees for 50 meters, and then 200 meters due east. So here, when she gets here, she moved in the eastern direction, moves in the eastern direction for 200 meters to point C. So we are to calculate how far she is from her starting point. So meaning we are joining A to C, and that is side this is angle B, so this is side B. We have to calculate side B. So to calculate side B, since we are given two sides and we are looking for the third side, so it is advisable you look, is it possible we get the angle at B? So let's see. This is the South Pole to this point is the same thing as 25 degrees. So this is 25 degrees, and we know that this is 90 degrees. So the total angle there is 90 plus 25, 115 degrees. So we are going to use a cosine rule. So the cosine rule we are going to use here is b squared is equal to a squared plus c squared minus 2ac cos b. So we have a b squared. What's our A? A is 200 meters. So 200 squared plus C. C is 50 meters, so plus 50 squared minus 2 times 200 times 50. Then multiply by cos B, and B is 115 degrees. So cos 115 degrees. So we evaluate these squares and the product here. Then 200 squared is 40,000 plus 2,500, and 2 times 200 gives 400 times 5 gives 20,000. Multiply by cos 115 degrees. Cos 115 degrees from our calculator gives negative 0.4226. 40,000 plus 2,500 gives 42,500. Here it is minus 20,000 times negative 0.4226. Negative times negative gives positive. So 20,000 times 0.4226 will give us 8,452. Summing this up, we have 50,952. So this is b squared. So to get our b, we find the square root of 50,952, which gives 225.73 meters. So the distance from her starting point is 225.73 meters. So we go ahead to calculate the bearing from her starting point. So to calculate the bearing from her starting point, we know this angle, we just calculated this to be 225.73 meters. So we are going to calculate from her starting point. This is her starting point. This is where she is now. So the bearing from there will be from this north pole up till the line joining A and C. We need to calculate the angle from the north pole up to the line joining A and C. So to do that, we need this angle A. So we are going to calculate angle A using the cosine rule. So cos A is B squared. B squared is 225.73 squared plus C squared. C is 50, so 50 squared minus A squared minus 200 squared over 2 times 225.73 times 50. So inputting all this in our calculator, we have the numerator to be 13,451.77563 over, simplifying the denominator, we have 22,572.5. Then simplifying, we have 0.5959. So A is cos inverse of 0.5959, and from our calculator we have it as 53.42 degrees. So now the bearing from her starting point will be 25 plus 53.42 degrees, which will give us 78.42 degrees. Since we are giving it in 3-figure bearing, we add zeros before the number, or we can write it as compass bearing to be not 78.42 degrees east. So that will be not 78.42 degrees east. So that is all for problem 1. We go to problem 2. Problem 2. An aeroplane flies from a town X on a bearing of north 45 degrees east to another town Y, a distance of 200 kilometers. It then changes course and flies to another town Z on a bearing of south 60 degrees east. If Z is directly east of X, calculate, correct to 3 significant figures, the distance A from X to Z, B from Y to XZ. This is extracted from WAEC. So we start solving the problem. From the problem, an aeroplane flies from a town X. So we need to locate town X first. So this is town X with the cardinal points on a bearing of 45 degrees to the eastern direction. It is in the northeast, and from the north 45 degrees. So from the north, this is the east. So we 45 degrees, we are going to divide this part into 2 equal half, where this angle is 45 degrees to another town Y, and town Y is here. So this is 200 kilometers. So the distance from X to Y is 200 kilometers. So then we move further. It then changes course and flies to another town Z on a bearing of south 60 degrees east. So on getting to Y, it changes direction. So it starts from south 60 degrees. So around this place, this angle here is 60 degrees to the east. So if Z is directly east of X, we have a Z here, and this Z is directly east, so we join the eastern line of X to western line of Z. So this is the diagram of this problem. Now what are we to calculate? We are to calculate from X to Z, from X here to Z. That's side Y, that's side Y. And we look at the angles. Now this angle here is equal to this angle, that's alternate angles. That's 45 degrees, meaning the total angle there is 45 plus 60, which is 105 degrees. And we can calculate this angle here, since X is joined to Z on a straight line. That's from the east of X to the west of Z. It means this angle here is 45 degrees. So this angle here is 45 degrees. So we now have two angles. We are looking for one side and we are given one side. So we can calculate the third angle here. Calculating the third angle, sum of angles in a triangle is 180 degrees. So we have that's angle at Z to be 180 degrees minus 105 minus 45 degrees, and that will give us 30 degrees. That gives 30 degrees. So we know this angle. Now we now have the three angles. Given one side, we are looking for the other side, so we are going to use sine rule. So the sine rule we are going to use here is going to be y over sine y is equal to z over sine z. So we don't know y. Over sine y, see the angle y, 105 degrees, that's over sine 105 degrees is equal to 200, because z is 200, over sine z, that's over sine 30 degrees. So from here now we multiply both sides by sine 105 degrees, so we'll be left with y equal to 200. What is sine 105 degrees from our calculator? We have it as 0.9659. Then divide by sine 30 degrees, which is 0.5000. So press your calculator. We have it as 386.36 kilometers. And to three significant figures, we have it as 386. 1, 2, 3. The first three figures are the three significant figures. So this next number is now up to 5. We reduce it and ignore it. So we have it as 386 kilometers. So the distance from X to Z is 386 kilometers. This is to three significant figures. For problem B, we are to calculate from Y to XZ, from Y to XZ, this XZ. So we need to join the line from Y to XZ. So we call it a H, and which is automatically the height of this triangle. Remember, this is 90 degrees. If we take this angle 45 degrees as angle of reference, is going to be the given angle, and the opposite side is H, and the hypotenuse is 200. This triangle here, this triangle, this is an isosceles right angle triangle. Isosceles because the base angles here are equal. So this is 90 degrees. So we are going to use trigonometric ratios by combining the opposite and hypotenuse. We are looking for the opposite and we are giving the hypotenuse. So we are going to use sine. So we have it as sine 45 degrees is equal to h over 200, and that will give us h equal to 200 multiplied by sine 45 degrees, which is 0.7071. From our calculator we have 141.42 kilometers. To 3 significant figures we have it as 141 kilometers. This is the end of this problem and the end of the tutorial. Thank you for watching. Please subscribe to our YouTube channel Oninab Resources, like and share this video. Till we come your way again, goodbye.